Hi guys, welcome to lesson 3 notes over transformations. Um, so whenever you have a quadratic graph, this is just like the basic function for it. And it doesn't matter if it's y or x squared or f of x. Y equals x squared or f of x equals x squared is called the parent function. It's just like the basic function. When we start doing stuff with it, um, this is the kind of transformed function of that. And so we're going to talk a lot about that equation and the roles of each of those letters in the equation. So let's start out with this guy, k. So k is going to either move it up or down. So if k is positive, we're going to move it up. And if k is negative, we're going to move it down. So in this example, I have x squared plus 2. So our k is 2. So that means that I'm going to move this parent function right here up 2. So it's going to start here, and I'll show you what that looks like. So do you see this right here? Notice it's shifted up 2. Okay, H, when you have parentheses, that is when H is involved. And so that either moves it left or right. If this is in here positive, it actually is going to move to the left. And if it's negative, it's going to move to the right. So if you'll notice, this is x plus 3, and it's moved to the left. 1, 2, 3. So if it said, like, how is this transformed, I would say left 3. Okay, the next one I want to talk about is A, and a vertical dilation is going to pretty much make it look fatter or skinnier, but we're going to use some technical terms here. So if this number is bigger than 1, it's going to make the y values go up by a factor that's bigger than the parent function. So what that means is it's going to make your graph look skinnier, and this is called a stretch. When it is less than 1, so a lot of times you're going to see a fraction, but the closer this gets to 0, the wider this graph becomes. And so this is called a compression. And on your test, you're going to need to know those two terms, so stretch and compression. But it always will come before the x squared. Okay, something else that comes before the x squared, and it's also considered part of A's job, is if A is negative, this is called a vertical flip. And so what that means is, like, here's the parent function, and what it does is it flips it over anytime you have a negative out in front. So on the test, it's going to look something like this. So literally, I'm looking through anywhere I see a negative right there in front, like in front of the x squared, I'm going to say vertical flip every single time. So vertical flip. Okay, so when I come down here, and we're describing the transformations, think about, like, this is your H and this is your K. So the job of H is to move it right or left, and the job of K is to move it up or down. So for this transformation, for number 1, I would say right 3 and up 4. That. Like for this one over here, I would say left 2 and up 7. Here, this one's easy. I'm going to say down 8. This one is down 9. And this one is up 1. Oops, I forgot that one. That one is down 3. So I like the H and Ks. I think they're pretty easy. And personally, I like to start there. The only other thing that we haven't talked about, I'm going to do this in a different color, is the like stretch and compression. So remember, if this is bigger than 1, I'm going to say a stretch of 2. And in this one, I'm going to say a stretch of 5. Let's see. Oh, right here. Oh, look at these two. These two are less than 1. So I'm going to say a compression of 1/6 and a compression of 1/3. Okay, so notice that this negative and this number, really don't have anything to do with each other. They have two separate jobs. So make sure on your test, you're not just seeing like one or the other and just forgetting the other one. So let's go through here. Let's see. Number one, I just want to make sure we have everything. Yeah, so notice like some of them I only like, there's only two transformations, where some like you can have up to 4. So it just kind of depends on the problem. Okay, so let's talk about, again, let's kind of review the letters, the jobs of the letter. So A has a lot, like A can be positive or negative, and positive is going to make the parabola look like that. Negative is going to make the problem look like that. So negative would be a vertical flip if we're talking about transformations. A also, if A is bigger than 1, that's going to be a stretch. And if A is less than 1, that's going to be a compression. So A has a lot of jobs. H is always going to involve parentheses if we're doing an H, and so that's going to move it left or right. And as I said before, H is always opposite of what you should think. So like if it's like X plus H, that's going to move it to the left. And if it's X minus H, that's going to move it to the right. And K is always up or down, and a positive K means up, and a negative K means down. So those, and again, we've talked about those before, but I just kind of wanted to go through those before we get to our next section. So our next section says, write a quadratic function for the given transformations. So what I like to do is I like to take this function and just copy it down. And I'll give you this function on the test. Like that. And I'm going to do this to all the numbers that you see here. Okay, so why I like to write all the numbers or write all the formula down is because this kind of like, as I go through and kind of read these directions, I'm going to kind of ask myself, okay, which letter does it apply and which letters aren't being used? So vertical flip, that means that that's going to be a negative there. So I'm going to cross out the A and put a negative, and then shift it down 1. That means that K is going to be a -1. What this also means is that I'm not using an H, so I'm not going to have parentheses. So it's just going to be X squared with no parentheses. So my final answer for this one is going to be Y equals negative X squared minus 1. So that's how those work there. Let's do another one. Vertically stretched by a factor of 3. Okay, again, that's A's job. So that's going to be a 3. Shift right. So let's look up here because H's are always confusing. So that's going to be a -5. So I'm going to say X minus 5 squared, and then up 1 plus 1. Okay, so let's see what this looks like. So I'm going to say Y is equal to 3x minus 5 squared plus 1. Okay, let's do this one. Oh, look, this one doesn't have very much happening. So shift up 5. So that just means the K is up 5. There's nothing going on here. There's nothing going on here. So again, no parentheses. So it's just going to look like an X squared. So it's going to be Y is equal to X squared plus 5. Okay, and this one, that should be a V there. So vertical flip and compressed. So we have these two things going on, which are both A's. So that means that it's going to be a negative because of the vertical flip and a 1/2 because of the compression. So negative 1/2. And then again, no parentheses because I'm not using H and I'm not using K this time. So I'm just going to say Y is equal to negative 1/2 X squared, and I'm done. Okay, what if we have a graph? So what is the equation of this graph? So the first step that you need to do is find the vertex. That is going to really help you. So right here, our vertex is going to be 3, 1. And then again, I'm just going to put it back into that formula that we used before. So this is my H and this is my K. So my equation is going to be, I don't need to worry about the A unless it's like going down, but that one's not. So it's going to be X minus, 3 squared plus 1. Okay, let's do it over here. So my vertex right here is going to be -2, +2. And so I'm going to say, let's see, so if this is a -2, that's going to make it a +2. So I'm going to say x plus 2 squared plus 2. But notice how this guy, do you see how he's going down? So that a is going to be a negative, and I need to include that. Okay, so what if we started doing things to this graph? So what if I made it go left 1 unit and up 3 units to create a new graph? Well, I'm going to really focus on, the vertex. So let's see, I'm going to go left 1 unit and up 3 units. And so that's my new vertex. So my new vertex is going to be, let's see, 2, 4. And so I'm going to put that into my equation. So I'm going to say y is equal, and the only thing you change is, so if there's like a number out here, you would keep it the same, but it's not. So the only thing I'm going to change here are these two numbers. So I'm going to say x minus 2 squared plus 4. So in other words, over here, that negative is still going to be there. Okay, so let's see what our new vertex is given our directions. Okay, so it's translated to the right 5 units and down 4 units. I'm actually going to start here because we're going to run out of space. So let's see, 1, 2, 3, 4, and then 1, 2, 3, 4, 5. Okay, so what is that? That's going to be, let's see, 3, -2. So I'm going to say x minus 3 minus 2 for my answer. Okay, so the last thing we're going to talk about is increasing and decreasing intervals. And where it's at is the axis of symmetry. Okay, so I'm going to pretend that this axis of symmetry right here is at, I'm just going to say x is equal to 2. So if I cut this parabola in half, can you guys see how there's a piece over here to the left and there's a piece over here to the right? Okay, every single time. So think about this is like a number line. So all of these numbers would be less than 2 because of our axis of symmetry, and all of these numbers are going to be greater than 2. Okay, so we're just going to kind of table that for a second. We'll come back to that. And so this is where, just think about like a roller coaster. So if you're going downhill, you're decreasing. And if you're going uphill, you're increasing. So when it's asking for like, where is it increasing? I'm going to look over here and say, okay, it's increasing at x is greater than 2. Okay, where is it decreasing? It's decreasing right here at x is less than 2. So that's how that works. It's not too bad. You just have to know kind of what to do. But the main thing, again, is finding the axis of symmetry. So the axis of symmetry is at x equals 4. So everything over here is at x is less than 4, and everything over here is at x is greater than 4. Okay, now I'm going to kind of figure out, okay, we're going uphill on our roller coaster, so that's increasing. And over here, we're going downhill, that's decreasing. Okay, let's answer those questions. Where is the graph on the left increasing? Okay, well, I have everything I need now, right here. It's increasing at x is less than 4. So that means it's decreasing at x is greater than 4. Okay, let's do this again. So here's my axis of symmetry at x equals 2. So over here is x is less than 2, and over here is x is greater than 2. Here I'm going downhill, so I'm decreasing. Here I'm going uphill, I'm increasing. Okay, so where is the graph increasing? So right here at x is greater than 2. Where's the decreasing? Over here at x is less than 2. And that is it, guys.